Welcome to a new test and teardown video. This time it's another Hewlett Packard. And this one is a 3495 scanner. That's actually all there is here on the front panel. It's of course an IEEE scanner, and it's from about 1974. There's only one thing to push here on the front, and that is the line on off, and there's nothing else to push or dial around in. And then there's a display that will tell us which one of the channels that is selected. So the whole idea about this unit is IEEE remote controlled modules, where you can relay switch or matrix switch all sorts of measurements for test systems or automatic test setups and such. So let's look at the back. So this is the back panel. I think what we see here is a homebrew kind of interface for some of the internal modules. It looks like we could probably just unscrew this and just flip this out. So probably some analog and some digital interfaces here. RF test system number 6, and the address is number 9. And of course the IEEE connector, synchronization, mains input, voltage selection, and probably a little power supply. I think we should open it and then inspect it a little bit more before I try and power it up. So that was quite easy, just those two screws, and then you can flip out that back panel. That's actually really nice and smart the way that this is made. So that will be for some interfaces for that, right? And all the cables for some plug-in modules. Aha, let's open the lid. Let's have a little look inside. We got 3 plug-in modules, and there's actually room for a 4th plug-in module. I think you need some sort of interface circuit boards like that as well. And then there's a little power supply. There's only a 5 volt and a 12 volt positive supply. Just for the logic. In here is the IEEE interface. We could probably pull this out and inspect that as well. And that will be the transistors for the 2 power supplies. On the heat sink, mains, transformer, rectifiers, capacitors, and the logic for the power supply, right? So let's have a look at how do we do that. You can only pull them up when the plug-in modules they are pushed out. That's quite nice. It's also a little bit funny with this little adapter board. So if you remove the IEEE board, then you can pull out that little board. And then there's this. That is really beautiful. It's really beautiful design. I mean, and then you have some. I think there's actually a little bit of logic and control stuff. We got some LED here, and it looks like there is this circuit board here goes out to the front. So there's definitely a circuit board more in here, but I don't know how we can clicky open this, or need to inspect. So now I took out the 3 plug-in modules, and this one here in the middle fell apart, so I would assume this is a 20 channel connector assembly. Aha, interesting. So that means there are some sort of connectors we can, and then just for connectors, and then we got those modules. They are of course different. No, they're not. So this one is just option 4, whatever that is. Okay, full of relays. And what? That is interesting. I gotta have a look at that. Very, very heavy. So are they the same? This looks actually a little bit like the modern types as well. I mean, I can still see where the basic idea is coming from. The way that the wires go through here, and then we can screw in all the different connectors, and then you can plug it into your modules and all that kind of stuff. It's super versatile for whatever kind of test systems you're building. And it looks like we can have analog signals and digital signals and high and low speed and all that, gold plated. It's quite nice. So now I'm trying to get into the relay matrix, and as you can see, we got some signals going on that way and on that way, so you can completely matrix everything. It's full of relay coils. Let's try and open it a little bit more. So now I'm a little bit more inside the relay module. I think you can see some reed contacts down there, and I believe we got 3 relay contacts, and then there is a shield hit here. I mean, try and look at this back plane shield, and it's connected to the metal frame and all that casing. But look at that, there's a thin track that goes to the next one, and here a track that goes to that one and to that one. But then there's no track here, only that tiny little track here. So what is the idea about that? And they are numbered, some of them are numbered. See, that is number 4, 8. That is a little bit funny. And look at that number, 3 and 23, 8, 88. So that is 1988 probably. Somebody was using this the last time. And that is probably 1975. So it is that old. Let's try and see if we can get a little bit deeper into that sandwich here. Oh, you are going to love this. Reed relays. But let's inspect them a little bit closer. They are rotated completely random, or at least so it seems. I can't make any kind of system out of this, but they're not in parallel. They're connected all sorts of weirdo ways, and it looks like they're completely random, the rotation. So that is really weird. There's actually one more thing I really want you to see on this card. See the traces here? So those are inlay traces. The outer layer here, that's of course gold, but this black trace here is inlay trace, and it ends in a little dot like that. So there's a buried via interconnect between the two inner layers, and there's this buried via technology. That would have been absolutely state of the art in 1974. I don't know, or is it a God trace? I don't know exactly what it is. Could also be a God for isolation, but it's probably connected to, yeah, you see, it continues on the other inner layer here, down here. So it is some kind of special technology here. Wow, that is some nice card. And by the way, it was mounted like this, right? And then a normal thickness 1.6 millimeter 2-layer board for shielding again. And then our inductors, oops, I hope that didn't smash my scope, man. So, and the fun thing is here, they are connected magnetically, see? And 2 and 2, yeah, exactly. So this one goes down and up again. How then? How did that work? So if it's mounted like that, right? Okay, so the other end is just not touching anything. That is just a loose end. All right. Why would you do that? Maybe it's like that, right? Aha, it is in the middle. Yeah, it is in the middle. Okay, now I completely get it. Those two ends, right? They are here and here actually. So the magnetic field goes this way through, and that means it doesn't matter what kind of rotation we got here, and it will just make them go together every time there is a magnetic field. Wow, man, that is some special way to do that. So that will be the relay driver boards, and that will be the 20 outputs and some logic you can address through this. It doesn't really look like it's multiplexed or anything like that. Well, maybe it is, or addressed at least. So on this dip switch you probably set the address, and then you can access. Oh, look at the layout here, it's just manually done, right? The way that the tracks are done like that. This is done before computer technology, so it's definitely just done on film. Really nice. I can't wait to try and power this up and see what is going to happen really. I want to try and pull out the IEEE unit as well. So this is the IEEE interface, done completely using just gates. There isn't any fancy smancy parts here really, or are they programmable chips from MMI? Yeah, they could be those 27S. Yeah, I think those are actually some programmables. But other than that, yeah, just a discrete gate and a crystal oscillator. It's actually really beautiful. And a little spider egg. Yeah, address here is hardwired. I kind of like those layouts. That is so nice. Yeah, let's try and put it back in and see what happens. I figured it out, how to get in here. And yes, I was right about the PCB that went from the relay selector board. Controls, of course, the readout of the selected channels. So when you plug in a new relay board, you of course also buy the relay driver, and that one also needs a readout. That is not mounted by default, so you need to get in here as well. But that is really easy. As you can see, those stick through here, and then you just loosen the screws here. Oh, that is super easy. That's just the power on. Let's try and power it up and see if there's any kaboom inside this thing. I don't expect this thing to be able to do a whole lot of something because there is no CPU in it. It's only logic gates and a crystal oscillator. That's more or less all I was able to find. So let's just see what happens if we power this up. Yeah, exactly. Of course, nothing gets selected, nothing happens because you need to write IEEE commands to actually enable any of the relay drivers and thereby turn on the indicators for the selected channels. So all you get is a green LED if you do not send any IEEE commands.